What you saw just a few seconds ago was a bunch of mess on my desk. But we always start out with the pyramid because hopefully we want to be in a state of transcendental meditation before we get this party started. It took me an hour to find something, and then I found something else, and I'm like, oh my god. You know? It's like, wait till you see this stuff. I'm going to set up my stream here really quick, and then we're going to get this party started. Basically, what I'm going to do here is just go over some of my components. And so, originally I was going to make like a small preamp with what's called an FET, and it had a range of, at least 100 megahertz, okay? So, like a wide bandwidth of 100 megahertz. And then that was going to go into a 2N222, or 2N2222, whatever. It's like another little preamp thing. You know, those, like the 2N2222 is NPN. And typically those transistors are a little bit more noisy. Um, so there's the idea about having the filter before the amplifier. Then there's the idea of changing the phase of the signal, that the carrier that has the object under test. And I thought I was doing that with an amplifier, and come to find out that's actually not going to be done electronically. It's going to be done mechanically, and it's done by moving the second mirror in the interferometer. Which, okay, you know, that's good because that really alleviates a problem. But of course, when you do that, I think that entire mirror, I'll have to make an adjustment for the entire mirror on that. So that part of the design hasn't been done yet. What else? So let me just go ahead and work on this here. I'm setting up my stream, and what we're going to do is, like I said, go over my components. So I know for a fact that I have what's called these SMT surface mounted items, and they're built with like what's called a flat pack. You just kind of plop them down on the copper, and then you make the traces, and you solder the lines to the surface mounted device. So there's that business, and that's probably what it is that I'm looking for. Right now I'm almost done setting the stream up. I don't really have a lot of time. I have to go to work. Oh god, I don't even have my phone. I think I have to be to work at 2:30 today. That means I have to get up at 2. That means I need to pretty much go to sleep in an hour. So that's that business. And that's done, that's done, that's done, yada yada yada. And this is kind of not done. Shit, I gotta move this over. Wait, this is supposed to be like over here. And that's supposed to be over there. So yeah, let me just double check my time here somewhere. This goes over here. Okay, so yeah, that's the lovely pyramid. Now we can go back to my lovely mess over here. Let me just adjust this camera a little. So, I was in a box, and I was looking for this stuff here. There's another bag of stuff inside of this bag. It's a static bag, and it's got my stuff in it, right? So I found some stuff here. This is like, look at this. This is like brand new, right? And I think this stuff, I didn't order this. This was something I got for free at the Ham Fest. And I transistors. I've got a bunch of these, and they're what's called like metal can transistors, right? And so you can put heat sinks on these and send these down to a lower value. And I really don't want to open up the bag to find out what it is. It's an NEC C1426. NEC C1426. So what we're gonna do is I'm gonna look up a few things. Let's see here. We go to this and we type in NEC 1426. We're gonna get to the good stuff in a minute. Okay, it's what the fuck. Alright, so oh wait, it's supposed to have a C in front of that. Okay, NPN transistor type bipolar. Consists of I don't just give me the damn thing for it. Oh look, they've got them for sale on eBay. Holy God! Are you shitting me? Are you freaking kidding me? On eBay. Listen to this. $15.44 a piece. What the F? Wait, this has got 4 leads? No. Looks like it has 4 leads. And it's got 7 available. I've got 1, 2, 3. I got 5. This is a 4 lead, brand new in the bag. $15 a piece. Wait, 15 times 5? What? $75 in one bag? Wait, they don't even tell you what the hell it is, okay? Where is this dude selling this shit from? We have that item. Yeah, okay, you can KMA, okay? Just because I'm... Now he's... Oh, God, his price is... 2 pieces of these power transistors. $10. Oh, my God, all freaking mighty. You fucking kidding me? Alright, so this one... There's the data. Is that the data sheet? It would be nice. Okay, PDF, please. Download. No, I'm not going to allow ads on your effing site, okay? Enter the code. Enter the code. Oh, we want to make sure you're real. Enter the code. F you. Oh my God, it's in fucking Japanese. You fucking garbage. What is this here? It's in fucking Japanese. Frequency 200 megahertz. NF noise. It's got a noise figure of 4 dB with a current of 30 milliamps. An RG of 50 ohms. It's a 3.5 watt. Minus 65 degrees to 200. But there's 4 pins. There's a case, collector, base, and emitter. I don't know why they would have a case there. Pulse width 350 microseconds. DC current gain versus collector current. Gain, bandwidth, frequency in megahertz. Wait, what the fuck? No way. 2 gigahertz? No frickin' way. This is not a 2 gigahertz amplifier. Noise figure versus collector current. Third order intermodulation distortion versus collector current. Second order. Oh, they don't really give you a bunch of shit here, do they? What a bunch of garbage. Oh wait, this says NPN high frequency wideband amplifier industrial use. What the hell? No freaking way. FT is 2.5 gigahertz. MATV, CAT TV, CAT TV amplifier. No freaking way is this a 2.5 gigahertz amplifier in a can. Minimum. It says minimum 2 gigahertz. What the fuck? Come on, what's going on here? And then it says, I don't know what the hell is going on. I can't understand what this is saying here. This is bullshit. Oh my god, give me something else. Oh my god, it's just going to the same effing place. Unknown manufacturer. I gotta click through half a dozen. Look, that's Japanese too. Goddamn fucking bullshit with this shit, I'm telling you. Yeah, you're gonna hear me cuss. That's just what I do. I don't mean to do it like intentionally. PDIP, NPN transistor, data sheet. Minimum operating temperature 0. 730 milliwatts. Output current 1.2 amps. Where else are we at here? Price. View offer. Take your security check and shove it up your A-double. $1 a piece if you get 60 or more. I need more information. Best price in Egypt. $23 a piece on eBay. What the fucking hell? Buy two and you get them $20 a piece. They don't even tell you what it is. You know, these fucking garbage people have this shit. They have no idea what it is. Not a fucking clue. We don't know when or if this item will be back in stock. You don't even know what the fuck it is, you freaking morons. Currently unavailable. Zero customer reviews. This old stuff, it's hard to find any information for anymore. Small signal. Yeah, right, okay. Alright, that's fucking garbage. Let's try this here. Generate answer. Silicon. Complementary to 2SC 1473, etc. Yeah. I don't want all transistors, do I? Silicon maximum ratings 20 volts. a collector current of 200 milliamps, and the other one said 1.2 amps. These fucking assholes. Transition frequency 1 gigahertz. The fuck? What is a transition frequency? I may have gotten lucky here. But what about noise? Well, it does have a noise figure. A measure of the high frequency operating characteristics of a transistor uses similar as FT, a characteristic of spectral lines, the frequency of the radiation associated transition between hyperfine structure energy states. Well, that's interesting talk. What the fuck? They don't even fucking wikis. Oh, God, help me. Well, it's an NPN transistor. That's a good thing. Transistor 300 megahertz and the latter typically. Now, what is the transistor frequency? Simple. Radio amateurs planning to design radio frequency will be interested transistors with higher transition frequency, which we often call RF transistors. Yada yada. GPS system. And this jackass got no answer, which is typical. Transition frequency of a transistor. Frequency at which its current gain drops to 1, indicating the upper limit for current amplification. Crucial to determine how well a design can operate high frequencies, etc. Okay, so 1 gigahertz. The SDR goes up to 2 gigahertz. Might act as a buffer between 0 and 2 gigahertz. I wish there was a chart. Let's see here. Noise figure, low noise figure. Here it says typical 2.5 gigahertz for the transition frequency. That's some shit, huh? Are you kidding me? Oh, what is this? Temperature junction 50 degrees centigrade per watt. I mean, this thing's kind of high powered. Minimum is 2 gigahertz, 10 volts, with a collector current of 50 milliamps. This will amplify signals up to 2 gigahertz. Current gain versus collector current. HFE is 100 up to 50 milliamps. Like between 10 and 50 milliamps, it's got a current gain of 100. Gain bandwidth product is 2 gigahertz between 10 and 50 milliamps with a collector emitter voltage of 2 volts. Noise figure. With collector current, the noise figure goes up. So at 10 milliamps, the noise figure is a lower number. RG, what the fuck? That says 50 ohms. What is RG? No, that's got to be RC. I think that's RC. That's all it tells you. V output. V output 100 dB microvolts at 75 ohms. 75 ohms, that's close to 50 ohms. Oh my God, can I use this? I got this for free. What the hell? You know? This is just in this bag of stuff, and this is like this kind of a transistor. Like I don't have to deal with the SMT stuff. But then there again, there's the noise figure, right? What the hell, huh? Okay, so I'm just gonna. I got 5 of these, so I'm gonna put this up here. But that was a lucky find. What the hell? So all this other stuff, like you know, I've got stuff like this, and I think this is a dual timer in a can. Like you probably can't see what I'm doing. I don't even know where I downloaded this stupid thing here. Open in folder. I want to grab this and put this. Oh shit. Let's do this. Goes over to here. And then this one, because I need to send that to my shit too. What is this? Quantifying the triboelectric series. The hell is this? Triboelectric charge. Copper. Tested material. Mercury. What in God's name is all of this shit here? Triboelectric series of materials and their triboelectric charge density. Micro C per square meter. Standard deviation. No. Huh. I have no idea what the fuck that shit is. Anyway. Let's see what this is here. Oh yeah, I wanted to get my Streamo thing back up. Well, that was pretty interesting, huh? So I got this little can thing here. And let's see if we can check out the number on this. Yeah, I don't know what the fuck that is. I don't care. I've got a bunch of stuff in here. See? I got a crap load. I mean, I have got so much stuff that it's not funny. This looks like a power. This is not a power amplifier. What is this? Yeah, I think it is a power amp. Oh, wait. It's a 5-volt regulator, which has been used. And some diodes in here. These are germanium diodes. Wow. Nice. Super freaking nice. I need the germanium diodes because I want to build. Oh, these are really small and they've been taken out of something. But anyway, then there's another device here, which is super duper fucking small. UD4001. Let's find out what that is. Sorry about the language. It's like, what the hell? I gotta go back to work for another 5 hours. I'm not too typically happy. Oh, that's not gonna work very well, is it? I am sort of happy, but it's like I need to go back to sleep, you know. It's not a diode. High frequency rectification. What the fuck? It says it's a diode. Oh, what is this? 200 megahertz bandwidth, programmable charge pump, 3-wire serial interface, analog to digital. 200 megahertz clock generator phase lock loop data sheet. They require very low noise, stable reference signals. (200 megahertz bandwidth). Low frequency phase lock loop. Functional block diagram. 24-bit input register. RF input frequency megahertz, minimum max at least 5 megahertz, 5 to 165 megahertz. Frequency less than 5 megahertz, use DC coupled square wave 0 to VDD. We get a lot of wind today. Logic inputs. Timing characteristics. Pin configurations. Okay, this is weird because this is not what my chip looks like. My chip has, it only has, oh, it has 5. It's 5 in, it's got 5 on each side. This is not what it looks like. This is different. I don't know what this is. This is not the same thing. Well, I'm not going to worry about it. I got a bunch of these. There's these little things here. Shit. So they look like this. Yeah, I got a bunch of these, which I really can't do anything with. I've got another phase lock loop chip. Okay, so it's that, which I got so much crap, I swear to F. I got so much stuff, it's not funny. I got this one, I got this little guy right here. It's a nice another metal can. And I think this one, this is a MC1533G. I thought that was a timer. MC15. I've got problems with my left wrist. I don't know if it's carpal tunnel or what it is, but I woke up this morning and it was really hurting. If I move it around, it kind of goes away. I don't think it's carpal tunnel. Like, I don't know if it's the way I'm sleeping. You know, I don't know what's going on. Discontinued product. Operational amplifier. Operational amplifier. That says refurbished. $16 a piece? Oh my god, this shit is fucking expensive. $23 a piece. Good God. Are you fucking kidding me? Bunch of fucking morons trying to sell this shit. Request free CAD models. Download library loader to convert this file to your eCAD tool. Jesus, just give me the fucking data sheet here. Let me get to the good stuff. Let's see. Let's try. I don't know what that is. Let's try this one. They put these fucking numbers on here, and to disguise what you're trying to look for, so the AI can't find it. This is a different package. The different packages probably have a little bit different characteristics. V in, V out, typical application, but this isn't, what the fuck? Ultra low dropout regulator. Oh my god, I give up. I'm not gonna deal with this shit right now. I'm just going to take this, and I've got a little one of these. I found this thing here. I found a couple of, I got this box, and it was just full of stuff at the ham fest. I'm a ham operator, you know. I'm a ham. And in the bottom of the box there's like a crap load of loose transistors and shit, and I'm like, oh my god, I struck a gold mine, you know. Let's see what this one is here. MRF 586. What the hell is that now? How many pins is that? It's a 3-pin. MRF 586 PDF. Advanced Power Technology. Microsemi Corporation. There's a PDF there with a number. HG Semi. Oh, I'm not even going to bother going to that fucking place. Let's see. An NPN UHF VHF transistor. Transition frequency of 3 gigahertz. The fuck? Goes down to minus 65 degrees C. I'm thinking about having a separate cold temperature room in my project. Damn, if I could, just a small area, you know. Like, I'm gonna do part of the case itself. I'm gonna kind of vacuum it out a little, and then cool it down. And then the dark area, maybe it's not gonna get vacuumed out, but it'll be a little bit cool. And then maybe with the electronics, once I get them built, maybe I could house them in a solid metal case, and that I think I could cool down a lot more. I could really get that baby cool. Current gain bandwidth product at 300 megahertz, 90 milliamps of collector current, typical 3 gigahertz. Gain bandwidth a 3 megahertz, no, a 300 megahertz gained with product at 3 gigahertz. Is that what that means? Maximum unilateral gain 12 dB at 300 megahertz. Oh shit, no, that's not going to tell me much. Let's put it in, this is in MRF 586. So I can develop circuits. I can develop a circuit for what I'm looking for and pop these transistors in there and run tests on them. You know, it'd be nice if I could just do this type of deal here. Okay, well that's an interesting component that's just stuck out there. You know, damn. This is a voltage regulator with germanium diodes in this box. There's these. Oh, this is a new one. Is this a new one? Yeah, what is this one here? I've got another one. C1426. Now wait a minute, isn't that what I just looked at? C1426. There's one package. I got another package. These are sealed in a sealed box, and there's 5 more of them. Oh my god, I could play with these to my heart's content. Wait, has this been opened? No, this is sealed. I got 10 of these. Oh my god. Oh my god. That's $200 worth of canned transistors. Oh my god, I want to pull my freaking hair out. What the F? Holy. Alright, what's this here? SRF 397. Let's check out this bad boy. SRF 397. These are just basic wideband amps that I'm going to build, but actually I don't know if they're going to be part of the preamp section or if they're going to be like, it just seems like I need an FET section in front, and then I need this kind of an amplifier somewhere in the back. Alright, let's see what this is. Bullshit here. Come on, wake up. What the fuck? SR. No, I'm not effing human. I'm a fucking robot, moron. Come on, wake the fuck up. Get all my information. Transferring data, transferring data. Yeah, when it does that shit, you know what I do? I say F you. I'm about ready to, but it might have something I need. Alright, you know what? F you. Alright, let's see here. There's another one here. IC2IC.com. SR, and of course it doesn't. SRF 397. Is that what I said it was? SRF 397. I just want to make double sure. Yep. There's a bunch of them. That's not a static bag, by the way. I'll show you that in a minute. Inquiry. Data sheet. Inquiry. F you. Oh my god, not there again. I got this one place that's got all this fucking data shit in, I swear to god. I can't find it here. I'm not gonna deal with this fucking shit here. Screw that place. Alibaba. This product is unavailable. I don't give a shit. Give me a fucking data sheet, will ya? Oh my god. Just give me the data. I don't want that. No, just a minute. No, I'm not fucking human. I'm a friggin' moron. Shelf life of 12 months. My ass. Are you serious? Again? It just keeps redirecting me to the same fucking website. I don't think I can find it. Oh my god. Why am I going to the same website all over again? Alright, let's try this. It's sending me to this all data site. And I just have no fucking choice, you know? No data. No data. All data sheet can KMA. That one's no good. HK inventory. That one's no good. RF parts. RF parts company. Oh my god. I can't do a search here. Wait, let's see. SRF397. Yeah, we don't have it. I'm so sorry. You have to go somewhere else. Goodbye. Have a nice day. Alibaba didn't do shit. I can't find any information. Oddball transistors. I don't think I'm gonna find it. Motorola RF transistor data sheet index to the main page. CB tricks. I'm gonna have to just run a test on it. I can't find it. I cannot find it. I just don't want to waste any more time for this. MRF. It's not on that list either. There's a bunch of MRFs though. Let me go ahead and pop this on my projects page. Alright, you know what? Let's just do this shit here. I want to get into my SMT package before I gotta quit, you know? What time is it? It's not there. Send an RFQ for this part. How about you kiss my ass? Oh, I found something. Wait. Request a quote. Quantity. They got 235 of them. 397. BY 397. 40. What is DS? Oh my god, it sent me to that fucking website. You gotta be fucking believing me. I'm gonna tell you what website this is. This is alldatasheet.net. This is, I don't know what the hell is going on. I can't get any information. $3.97 and no, I don't know. That's just garbage. I don't know what to do here. I don't know. Not a fucking clue. It's a junk file. Alright, what else we got? We got, those look like capacitors of some kind. Let's put this up here in the file. I bought these. Look at these old pizza speaker thingies. Uh-oh, I fucked up my camera, didn't I? Yep. So it's like a little pizza. They're just kind of stuck together. Shit. These little, I don't know what their frequency range is, but there's some stuff there, you know. Where did this even come from? That's supposed to be up there. Fuck, that's got a magnet in it too, so let's put that up on my speaker pile. Okay, and I'm hoping I can find, I wanted to find my piezo elements, but I don't know where they are. Okay, so this is probably bad, reason unknown. This is a 3LM311. So there's things in here, once I get going, I want to build test circuits and relearn my electronics and stuff like that, you know. There's an MPF 102. This is similar to the 3819. You know, that's a good piece of equipment. I've got MRS 3565. Let's see if we can find out what that one is. MRS 3565 PDF. Oh my god. Mrs. Oh god, I cannot deal with this. I'm gonna put this pile. I just cannot deal with this shit right now. This could be some diodes. It could be a Zener diode. Good god. I don't know what this is. This is a diode of some kind. My guess is it's some kind of a Zener. And it doesn't tell me anything. Oh, maybe we'll play with that one. Okay, there's some germanium diodes in here, which are new. And that's an interesting little package. Okay, this is new in a sealed box. This is the same kind of deal. I think this is a Zener diode. And if it is, it's something that I want because I want to build a regulated supply. What is this thing? This is an SMA. Oh, this is some kind of an adapter, which I don't need. MPS 918. I'm curious. put PDF and they send me to a bunch of other shit. Motorola, yeah, all data sheet. You can kiss my ass. NJS Semi, all data sheet. Rutgers. I want to find a place that gives me good information and then use that place. Now, this looks pretty good here. This is ECE Web at Rutgers. Minus 55 degrees. It's like 1 watt, a little less than a watt. Let's see if we can find. It's got thermal resistance information in here. MPS 918 collector emitter breakdown voltage 1520 collector cutoff current. It's got some good DC current gain. HFE is 20. I'm guessing that's 200 megahertz. No, that's 200 gain. Current gain bandwidth product. See note number 2. Frequency of 100 megahertz is 16 and 100. This has got a very large. I don't know exactly what this is. Noise figure. 6 dB noise figure. I think the higher number is actually better. Functional test, amplifier gain, frequency at 200 megahertz. This looks like a good unit, a good hardy. What is this here? Oscillator collector efficiency. You know, I can't get no more information out of it. 8 milliamps, 30 milliwatts, frequency of 500 megahertz. The efficiency is 25%, whatever the fuck that is. Common emitter amplifier power gain frequency 6 milliamps. 14 dB of gain. It's like a little separate amplifier, huh? Runs around 200 megahertz. I don't know. Let's save this file. Save page as electric programs. Okay. I like it. I want to keep it. I got 5 of those in there. It's like a side amplifier, you know, it's like something on the side. Oh, we've got some nice 100 ohm resistors. Okay. 47 ohm, which is close to 50 ohms. Okay, that's cool. 220 ohms, that's good for the LEDs. What in the holy hell is this? Something's in this. Microwave Associates Semiconductor MA4E525. 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 Yeah, that's gonna be really hard to find. I'm guessing it's a transistor. Oh, I'm not gonna find it. There's no way. I don't know what that is. That is one weird fucking. I'm gonna put this up here. I think that's a microwave transistor in there. Resistors. It's probably not too big. Now, this is a sealed package. What the hell is this? I have no idea what the hell this is. Oh wait, no, it's not sealed. has to do with mobile rates and shit like that. This is a code practice oscillator. Some capacitors. These are relays. I don't need that. Oh, I've got a shit ton of transistors in here. I've got a bunch of 3904s. Okay, I put that up there. Get some more big ass resistors. Don't need those. What's this one here? MC 1458. That's a dual op amp in a can. Wow. That's cool. Oh my God in heaven. What the hell are these? Crystal X? It's not a crystal oscillator. What the fuck is this? C1365. Well, let's see if we can find that one. I haven't even got to the SM stuff. Oh my God, I can't find it. It's coming up with some other bullshit. Yeah, I'm not going to be able to find it. Let's do, well, I'm going to go to this all data sheet because, okay, so there's there, data sheet. Yeah, I got to go through this goddamn bullshit with them. No, I'm not allowing ads. You can kiss my ass. I think this sends you to fucking Japanese garbage. I don't know. This goes up to 1 megahertz, minus 40, yada yada. Oh God, packaging, yada yada. This is garbage. An all data sheet just gives you garbage. It's a 1 megahertz amp of some kind. I don't care about that. Now here's a bunch of diodes. I love my diodes. 1N4002. Put them up there. IC operational amplifier that seems to be 500 milliwatt, 100 dB gain. Holy. Oh, this might be useful. This is a connector. I don't know what the fuck that is. This is a connector for something. I don't know. I think it's a solder-on connector. I can't even see it. I think it's something that goes in a... Wait, this is an adapter connector. I don't need that bullshit there. I don't know what this is. We didn't find out what this is, did we? We could throw that up there in the test bin. That's an amp. And this is a nice coil. Well, I'll put my coils up here. I got one more. Oh, I got two left. It's empty. No, this is, what is this? I'm sort of looking for power voltage regulators. Not necessarily power amps, but maybe. I think this is an audio amp of some kind. $400 volt. What is this, an SCR? $1.19. TIC. That curiosity is going to get me. TIC 226D. TIC 226D. Not G. I want D. I got about maybe 5 minutes left. Oh, you know what I should have done? Shit, I didn't. That Rutgers.edu site, I didn't go. Shit. Damn it. Let me go here. Maybe I'll just leave these websites up and look for it later. Yeah, why? I don't know what's going on. It's fucking up on me. I don't know what this is. Maybe I can mess with it. I don't know. Put it over there. What's this? Is this another one? This is another one. I got 2 of those. So if this can go fly, what is this here? Oh, it's a 220 ohm. So all this stuff can go fly here. That's gonna go fly where? I don't know where the fuck it's gonna go fly, but it needs to go fly so I don't have to deal with this shit. Alright, the goodie bag. We're finally into the goodie bag, and I got like 5 minutes. Yeah, that's the story of my life. This is the good stuff. Some of this stuff I ordered eons ago. Oh my god, look at this. Look at this shit. Oh my god, this is so fucking small. Are you effing kidding me? Look at the size of this shit here. Oh, what is this? This is a diode or something. Look. You can't even see him, can you? Like, you can't even fucking see him in there. Where's my magnifying glass? Oh my god, these are like little amplifiers or something. Oh my god. See, here's some more stuff in here. This is your SMT shit. So what I want to do is I just want to go through this really quickly. See if I can find. There's a desiccant bag. I don't think there's anything in there. There's a bunch of SMT. I'm not even going to show you this stuff because I'm looking for the RF amps. I don't even know where all this shit come from. Oh, you know, I know where this came from. Are you shitting me? I know where this shit came from. It just dawned on me. IC op amp wideband FET. God. Those were in a tube. Jesus. I don't know what this is. IC amp wideband amplifier. I don't have time to look these up. I think these are the ones. But I don't think these are the ones though. I've got caps. There's some transistor stuff in there that looks cute. This stuff, okay, I don't need this. Put this up here. This goes back in the goodie bag. You know what? I think these these are the amps right here, and there's no number on it. Let's see if I can get a number. Oh God, they're all 130. Like what the fuck? Aha, here we go. Part number ATF 13036. ATF 13036. Getting down to the wire here. ATF 13036 amp. Datasheet download. Agilent. Okay, we're doing good so far. Description. Related products. God damn. PDF. It's not giving me a PDF, you assholes. ATF. I wonder where the Rutgers thing is. I wonder if that's in here. Datasheet archive. I'm not going to all datasheets, so you can just kiss my ass. RF small signal transistor, yada yada yada, discrete. Okay, let's see if I can download. It threw an advertisement in my face and sent me to fucking KU band. Depletion mode. Okay, high output power, 17 dBm typical at 12 gigahertz. It's a gas FET. Frequency, 2 gigahertz, 2468112. NFO, dB, or W, what the fuck that shit is. I don't see an operating temperature. It's a 12 gigahertz amp. They don't show you. Oh, it shows you. Okay, so this is probably good. Let's see, file. Save page as. I don't give a shit about. Oh, fucking hell. Where's the damn PDF? Download data sheet. Huh, you fucking goddamn assholes. Fuck you. Yeah, go fuck yourself. It's a 12 gigahertz amp, that's all I know. Oh, it showed, you know what? It showed me the... Fuck. Oh my god, I lost it, didn't I? I did. Because I'm a fucking moron. Okay, I'm just gonna put this up here and collect the information on it later. There's a program that shows you how to do the surface mount builds. So I got a bunch of wideband amplifiers here, and I got that transistor one that I found. I might be able to use that. That would be really That would be a lifesaver. Wideband, op amp, another one. This is all SMT stuff. Yeah, this is really small SMT shit, which I really don't want to deal with. Wow. What's this? IC op amp, wideband. I don't even know what's in there. Try to just sell these and make money off of it, you know? I tell you what, where's my, this is my goodie bag, right? This is my garbage bag. Where'd my goodie bag go? So what I'm going to do is I'm going to work with that other, I got 10 of those other transistorized amplifier that go up to 1-2 gigahertz. Those will work for the SDR. So I'm in business. I'm in business to make you smile, baby. Alright, why don't I forgot where, okay, this is like in the box down there. But anyway, it shouldn't be down there. It should be, it was supposed to be in another box, but I'm not really using this crap. And it really needs to be away from magnetic stuff. You know what the fuck I'm gonna do? I have no idea. So yeah, we found the transistor that we're going to use, and we've got 10 of them. And there they are, right there. Check it out. Check it out, baby. Is this my garbage? Well, I'm going to leave that up there, because I got to call it quits. I got to go to work early today. There they are, right there. We got 10 of them. It's the, what the fuck is it? Let's see if I can find a circuit for it. C1426 data sheet. Let's see if that gives me some help. Well, that's the data sheet for it. But what about a circuit? Diode noise generator circuit. Ooh, nice, nice diode noise generator circuit. Yeah, they're not going to give me a lot of information, are they? So this is going to be my preamp. Diode noise generator circuit. Ooh, that's nice, whatever the fuck that is. So, there's a collector to base, 35 volts collector to emitter 18. What is that, like plus or minus 9 volts? No. Emitter to base 3 volts. Those are the max. It's a very, this is a very hefty. How can I even use this for a preamp? Oh, wait, you know what? So, maybe, oh, no. Oh, God. No. I think the curve was 10 milliamps. I could go for the noise The noise figure. Now see, the noise figure is low. I have to figure out my noise figure. That was a good. That was a comedic statement at the end of my stream. I gotta figure out my noise figure. Fuck. Uh, Third order intermodulation distortion. 2F1 minus F2. 2 times 190 minus 200 at 180 megahertz is it's down to minus. So if you run collector voltage at 15 volts, at 10 volts, it's a little better. It says the best third order intermodulation distortion is lowest at 45, a collector current of 45 milliamps. That's hefty. And it says 75 ohms. I'm assuming that's an output. The second order is minus 2, 4, 6, 8, 10, minus 62 dB. Minus 62. That's noise figure. What did I say? 45 milliamps? I did. Alright, you know what I'm going to do here? Is a higher noise figure better? No, a higher noise figure is not better. Indicates that the device adds more noise. So you want a low noise figure. Okay, so the low noise figure, well, I mean, it says 2 dB, 3 dB, 45 milliamps is like 2.5 dB. If I go for a lower current, it adds more intermodulation distortion. 35, so we're looking at 40, at least 40 milliamps of current. So that puts it around minus 2.5 dB noise figure. The output capacitance is in picofarads. It's around collector base voltage. Collector base picofarads. 1 or 2 picofarads. IC milliamps. 45. Current gain of around 100. Yeah, that's like really gain bandwidth product. The gain bandwidth product at 45 milliamps is around 2 gigahertz. Last thing of the day, gain bandwidth product is a measure used to describe performance of amplifiers, multiplies the amplifier gain and bandwidth. It indicates trade-off between gain and bandwidth, meaning that increasing gain typically reduces bandwidth, etc. Balance performance, increasing gain with gain amplifiers increase its bandwidth decreases. Increasing the bandwidth decreases the gain. 1 megahertz, they can provide a gain of 10 at a frequency of 100 kilohertz. Oh, so that would be a gain of 1, wouldn't it? So at 2000, the gain bandwidth product is 2000. Oh, that's that's at 2 gigahertz. Yeah, I'm not sure how that works. And I do have. Oh God, it's crazy. I don't know. I don't know what the input sensitivity is. It just tells you it has a gain. It doesn't tell you about input impedance or anything. So I'd have to have something that transmits in that range. Uh, God, I don't know. I don't know. It's like I gotta have a transmitter, like I can upscale frequency. I got a bunch of shit in here too that I discovered. It's an antenna. I'll show you this thing if I can get this thing out of here. Oh, that's just a light. I don't know. An oscillator. I've got oscillators that run up to 50 megahertz, 100 megahertz. My scopes only run 10 megahertz. When I use the microwave, let me see here. 2.45 gigahertz. Okay. Okay. That's good. 2.5 gigahertz. So what I can do is like when I can cook some food in the microwave or whatever, and I can put the detector right up next to the microwave, and what I can actually do is I can work on the SDR somehow, um, even that remote one, and see if I can see a 2.5 gigahertz frequency off of that, and if I can use that as my receiver, and then use the amplifier. I can connect an antenna to the amplifier and see if the amplifier will amplify that signal, and hook an antenna and get radiated. What am I gonna do, right? Um, we'll see what happens. I gotta figure some crap out. I gotta go to bed.